The overall goal of this procedure is to set up a high-throughput polymerization and assess the ability of a catalyst to undergo chain transfer through detailed characterization and kinetic analysis of the resultant polymer.
This method helps answer key questions in polymerization catalysis, leading to newly designed catalysts which can exploit chain transfer to produce efficient routes to a variety of polymers. The main advantage of this technique is that high-throughput polymerizations allow for efficient catalyst screening and direct comparisons of catalysts over a large range of reaction conditions. Demonstrating this technique will be Dr. Ryan Hugh, a postdoc in my laboratory.
First, dissolve 1 milliliter of 2,3-butane-dione and 2.8 milliliters of 2,6-dimethylaniline in 20 milliliters of methanol in a 100 milliliter round-bottom flask.
After adding 0.4 milliliters of formic acid, stir the reaction at room temperature until the diamine precipitates, which is typically 1 to 2 hours. Following this, filter the reaction mixture with a glass frit and filter flask, and wash the yellow solid with 20 milliliters of cold methanol. Then, dry the solid in vacuo.
In a glove box, combine 1 gram of dimethoxyethane nickel bromide and 1.1 grams of bis-2,6-dimethylphenyl 2,3-butane-dione in a 50 milliliter round-bottom flask.
Add 20 milliliters of dichloromethane and stir overnight at room temperature. On the next day, filter the reaction mixture with a glass frit and filter flask. Wash the brown solid with 75 milliliters of dichloromethane and dry in vacuo.